All right, so today we're gonna have our first ever mock interview
Yeah.
for our preparing for biochem talk, right?
Yup.
Okay, don't be too nervous. We're gonna start with an easy question,
Okay.
A-level standard.
Yeah.
I want you to draw on the whiteboard
Okay.
a pentanoic acid.
Pentanoic acid. Okay.
Yeah.
Yeah, so I'll use a pen. Um wait, sorry. I'll use an eraser to erase this part.
That's right.
Yup.
Okay. So in here you have correctly drawn the most important functional group,
Uh-huh.
carboxylic group.
Yup.
However, I asked you for a pentanoic acid. Pentanoic acid has 5 carbons, right?
Yeah.
In this diagram, what you have drawn is how many, right? There's
6.
1, 2, 3, 4. Yeah, exactly, 5, 6. We're gonna remove the last string. And this is the pentanoic acid.
Okay.
All right. I'm going to introduce a double bond here. Okay.
Mm-hmm.
Now it's still a carboxylic acid. However, it now has a double bond.
Mm-hmm.
Yeah. And we're going to explore how this might affect the physical properties
Okay.
of this two different carboxylic acids.
Uh-huh.
For physical, okay, so physical properties, we're specifically looking at the boiling points of these two molecules.
Okay.
The question is, which molecule has higher boiling point? Which molecule has higher point? I'll draw the original
Yeah.
pentanoic acid for clarity. It's a bit small O, but yeah, here we go.
Well,
Which one?
I'm not completely sure, but I think the answer would depend on whether it's more difficult to break two C-H single bonds or one CC double bond. And I would say that the double bond is probably easier to break, or is that intramolecular forces instead of intermolecular?
Yeah, actually, when we look at the physical properties, boiling point, melting point, we're always talking about intermolecular forces. What you just mentioned is intramolecular forces. What we're talking about is, let's say,
Okay.
let me draw another.
That's true.
Yeah, you made a easy, simple mistake, right? And we don't want to do that in
That was quite a rubbish answer.
Yeah, so we're talking about this intermolecular forces,
Yeah,
right?
I get it.
Yeah.
So in that case, actually I'm not sure.
Yeah, we need to look at how strong these, let me label it in a different color, how strong these intermolecular forces are. And what are these intermolecular forces? Well, let's specify that. You should always start with the simple, with the basic stuff.
Uh-huh.
Don't try and always say the most difficult thing to look smart. Van der Waals, GCSE stuff. Van der Waals, state those Van der Waals forces between the pentanoic acid molecules. However, the strength of Van der Waals between pentanoic acids and pentanoic acids are different.
Mm-hmm.
Which is bigger? Well, let's have a look. So let me just align two pentanoic acids. I'm gonna clear the diagram so that we can draw another one. And let me just draw this side by side. these are stacked, aligned, one after the other, obviously there will be another one at the bottom. Okay?
Yeah.
They've got a fairly regular van der Waals forces between the hydrocarbon chains.
Yep.
Right, let's look at the pentenoic acid, the one with double bond. Right, this is a trans bond I've drawn, right? But what if I draw a cis? I'm going to draw a cis bond. Oops, what is this? It's not. There's the stacking between pentenoic acids can be very irregular, meaning we are not going to get as much van der Waals forces between the hydrocarbon chains, right? Which means pentanoic acid is bound to have weaker intermolecular forces. Weaker intermolecular forces means there's less energy required to break these van der Waals forces, right?
Yep.
Which means at a lower temperature, this will boil. Therefore,
Yeah, I get it.
the answer would be pentanoic acid is the one that has higher boiling points. That's quite a good question, right?
Yeah.
Made you think.
Yeah.
Cool. All right, let's go into the next question. This will be harder.